Compressed natural gas can be used in place of gasoline, diesel fuel and propane. LPG.CNG combustion produces fewer undesirable gases than the fuels mentioned above. It is safer than other fuels in the event of a spill, because natural gas is lighter than air and disperses quickly when released. CNG may be found above oil deposits, or may be collected from landfills or wastewater treatment plants where it is known as biogas. CNG is made by compressing natural gas to less than 1% of the volume it occupies at standard atmospheric pressure. It is stored and distributed in hard containers at a pressure of 20 to 25 megapascals, usually in cylindrical or spherical shapes. CNG is used in traditional gasoline, internal combustion engine automobiles that have been modified, or in vehicles which were manufactured for CNG use, either alone, with a segregated gasoline system to extend range, or in conjunction with another fuel such as diesel. Natural gas vehicles are increasingly used in Iran, especially Pakistan, the Asia-Pacific region, Indian capital of Delhi, and other large cities like Ahmedabad, Mumbai, Kolkata, as well as cities such as Lucknow, Kanpur, etc. Its use is also increasing in South America, Europe and North America because of rising gasoline prices. In response to high fuel prices and environmental concerns, CNG is starting to be used also in tuk-tuks and pickup trucks, transit and school buses, and trains. The cost and placement of fuel storage tanks is the major barrier to wider, quicker adoption of CNG as a fuel. It is also why municipal government, public transportation vehicles were the most visible early adopters of it, as they can more quickly amortize the money invested in the new fuel. In spite of these circumstances, the number of vehicles in the world using CNG has grown steadily. Now, as a result of the industry's steady growth, the cost of such fuel storage tanks has been brought down to a much more acceptable level, especially for the CNG Type 1 and Type 2 tanks. Many countries are able to make reliable and cost-effective tanks for conversion needs. CNG's volumetric energy density is estimated to be 42% that of liquefied natural gas, and 25% that of diesel fuel uses. Motor vehicles worldwide. There were 14.8 million natural gas vehicles by 2011, led by Iran with 2.86 million, Pakistan, Argentina, Brazil and India, with the Asia-Pacific region leading with 5.7 million NGVs, followed by Latin America with almost 4 million vehicles. Several manufacturers sell biofuel cars. In 2006, Fiat introduced the Siena Tetrafuel in the Brazilian market, equipped with a 1.4L fire engine that runs on E100, E25, ethanol and CNG. Any existing gasoline vehicle can be converted to a dual-fuel vehicle. Authorized shops can do the retrofitting, and involves installing a CNG cylinder, plumbing, a CNG injection system and the electronics. The cost of installing a CNG conversion kit can often reach $8,000 on passenger cars and light trucks, and is usually reserved for vehicles that travel many miles each year. CNG costs about 50% less than gasoline and emits up to 90% fewer emissions than gasoline. Locomotives. CNG locomotives are operated by several railroads. The Napa Valley Wine Train successfully retrofit a diesel locomotive to run on compressed natural gas before 2002. This converted locomotive was upgraded to utilize a computer-controlled fuel injection system in May 2008, and is now the Napa Valley Wine Train's primary locomotive. Ferrocarril Central Andino in Peru has run a CNG locomotive on a freight line since 2005. CNG locomotives are usually diesel locomotives that have been converted to use compressed natural gas generators instead of diesel generators to generate the electricity that drives the traction motors. Some CNG locomotives are able to fire the cylinders only when there is a demand for power, which theoretically gives them a higher fuel efficiency than conventional diesel engines. CNG is also cheaper than petrol or diesel. Advantages: CNG does not contain any lead, thereby eliminating fouling of spark plugs. CNG-powered vehicles have lower maintenance costs than other hydrocarbon fuel-powered vehicles. CNG fuel systems are sealed, preventing fuel losses from spills or evaporation. Increased life of lubricating oils, as CNG does not contaminate and dilute the crankcase oil. Being a gaseous fuel, CNG mixes easily and evenly in air. CNG is less likely to ignite on hot surfaces, since it has a high auto-ignition temperature and a narrow range of flammability. CNG-powered vehicles are considered to be safer than gasoline-powered vehicles. Less pollution and more efficiency. CNG emits significantly less pollution directly than gasoline or oil when combusted. Unburned hydrocarbons, carbon monoxide, nitrogen oxides, sulfur oxides and PM. For example, an engine running on petrol for 100 kilometers emits 22 kilograms of CO2, while covering the same distance on CNG emits only 16.3 kilograms of CO2. Due to lower carbon dioxide emissions, switching to CNG can help mitigate greenhouse gas emissions. However, natural gas leaks represent an increase in greenhouse gas emissions. The ability of CNG to reduce greenhouse gas emissions over the entire fuel life cycle will depend on the source of the natural gas and the fuel it is replacing. The life cycle greenhouse gas emissions for CNG compressed from California's pipeline natural gas is given a value of 67.70 grams of CO2 equivalent per megajoule by carb, approximately 28% lower than the average gasoline fuel in that market. CNG produced from landfill biogas was found by carb to have the lowest greenhouse gas emissions of any fuel analyzed, with a value of 11.26 gCO2e/mJ in the low-carbon fuel standard that went into effect on January 12, 2010. Drawbacks: compressed natural gas vehicles require a greater amount of space for fuel storage than conventional gasoline-powered vehicles. Since it is a compressed gas, rather than a liquid like gasoline, CNG takes up more space for each GGE. However, the tanks used to store the CNG take up space in the trunk of a car or bed of a pickup truck which has been modified to additionally run on CNG. This problem is solved in factory-built CNG vehicles that install the tanks under the body of the vehicle, leaving the trunk free. Another option is installation on roof, requiring, however, solution of structural strength issues. In 2014, a test of Euro 6 heavy vehicles on CNG and diesel showed that CNG had higher consumption, but same noise and pollution of CO2 and particulates. However, NOx emission was lower. Codes and standards. The lack of harmonized codes and standards across international jurisdictions is an additional barrier to NGV market penetration. The International Organization for Standardization has an active technical committee working on a standard for natural gas fueling stations for vehicles. Despite the lack of harmonized international codes, natural gas vehicles have an excellent global safety record. Existing international standards include ISO 14469-2/2007, which applies to CNG vehicle nozzles and receptacle, and ISO 15500-9/2012 specifies tests and requirements for the pressure regulator. NFPA 52 covers natural gas vehicle safety standards in the U.S. Comparison with other natural gas fuels. Compressed natural gas is often confused with LNG. While both are stored forms of natural gas, the key difference is that CNG is gas that is stored at high pressure, while LNG is stored at very low temperature, becoming liquid in the process. CNG has a lower cost of production and storage compared to LNG, as it does not require an expensive cooling process and cryogenic tanks. CNG requires a much larger volume to store the same mass of gasoline or petrol and the use of very high pressures. As a consequence of this, LNG is often used for transporting natural gas over large distances, in ships, trains or pipelines, and the gas is then converted into CNG before distribution to the end user. CNG is being experimentally stored at lower pressure in a form known as an tank, at 35 bars in various sponge-like materials, such as activated carbon and MOFs. The fuel is stored at similar or greater energy density than CNG. This means that vehicles can be refueled from the natural gas network without extra gas compression. The fuel tanks can be slimmed down and made of lighter, weaker materials. Compressed natural gas is sometimes mixed with hydrogen, which increases the HC ratio of the fuel and gives it a flame speed up to 8 times higher than CNG.